Lately in class, we've been talking about how different traits could be selected for in nature. We've looked at environmental changes in our baby wolf pups and seen how that can affect the outcome of a pack. And things can vary, anything from ear size to fur color, all the way down to the height of a wolf. And today we're going to look at how the environment can cause these types of selection. So what we have here is a graph of normal trait distribution. I've been having you graph several different traits of the baby wolf pups all along. And what we commonly see in graphs is that the most common or the frequent form of a trait is the average. So in this example, we have that shown here in the middle. And then those extreme traits, or the less common ones, are on either side. And those are things like, rare traits. You might find something like some strange eye color or larger hands over here, with, brown eyes being in the middle. And what that gives you then is this bell curve distribution that we're going to see an awful lot of coming up. Here's our Shawnee Heights High School handspan graph that we made at the beginning of this unit. If you remember, everyone measured out their hands, and I think, there might have been a few that had some errors over here. But regardless, we can still see somewhat of a bell curve distribution here, looking at our graph. Of course, there's some variance and some deviations from that, but typically it still is following this bell curve model. So whenever we see a change to the bell curve, this typically can be a representation of the environment changing and the allele frequency within that population changing as well. And this is going to temporarily alter or change the bell curve distribution that we see. So if we look at the old and new bell curve, that can tell us how the population is exactly changing. So what you see here is maybe there was an environmental event with selection against some trait. In our wolf example, maybe that was the environmental event where there wasn't as much snow that winter and white wolves just were being killed off at a very quick rate, and the brown wolves were the only ones that were able to go on and reproduce and make new baby wolves. So then we would see our new population mean here, following in that brown trait, with the new population mean following right at the top. So directional selection is when a very extreme form of the trait happens to be the one that's best fit for the environment. And so it's going to shift that average from, maybe over here was the average used to be that brown fur was most common, and that's where our average was. But some event occurred where we selected against these white-furred ones here and selected against more common brown fur, and we're going to get our black fur following in this average here. So a possible example of this, I've kind of given you one there, the wolf fur color. Now, stabilizing selection is when the average or mean form of trait is actually the best fit in the environment. This creates a small range of actual trait distribution. So we could, I'm not going to give you an example here because I want you to try and think of something, but here's our bell curve distribution. What is an average trait that you see expressed? You could use a human trait, you could use an animal trait, a plant trait, whatever you may so choose, but brainstorm within the group that you're currently located in. What could an example of a stabilizing selection trait be? So an example that I gave was actually human birth weight. It's an example of stabilizing selection because this is the average, and typically you're going to see that birth weight does not vary within, too many pounds of the national average for baby birth. So that, again, is the average that is the most common, leading to a very narrow bell curve. Disruptive selection is when both extreme forms of the trait are best fit for the environment. So this is going to shift the average form of the trait away from the mean or the average. So maybe the average form fell right in here. And after whatever that natural event was or that environmental change was, you get a new average mean over on this side of the chart and a new average mean over here as well. So it's basically selecting for two different traits. An example of this are peppered moths. You can read this little story about peppered moths here on the side, but you can see this bell curve distribution that we just discussed in the last slide, noticing these two traits that are being selected for. This is really a very interesting story, though, about the Industrial Revolution affecting the peppered moth population. So summarize with the group that you're in a brief written paragraph about the types of selection that we've learned about, and be prepared for a couple of quiz questions on your exit slip today involving these types of selection. Please wait at your group until we choose to rotate.